Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test held in the month of March 2025. It is a rescheduled examination for Assam Center. In this video, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the bilinear forms. And this question is placed in part B, which is a multiple choice question. It carries 3 marks. The question ID is 706512. Further, this question is suitable for all these examinations. Right, the given question is: consider the real matrix A. It is a 3 by 3 matrix whose first row is 0, 0, 1, second row 0, 1, 0, third row 1, 0, 0. Define B, a map from R cube cross R cube to R by B of V comma W is equal to V transpose AW, where V and W belongs to R cube. Which of the following statements is true? We are given 4 options. Option 1, B of V comma V is 0 if and only if V is 0. Option 2, for every lambda belongs to R, the set of real numbers, there exists a vector V belongs to R cube such that B of V comma V is equal to lambda. Option 3, there exists a non-zero vector V of R cube such that B of V comma W is 0 for all W belongs to R cube. Option 4, if B of V comma W is 0, then either V is 0 or W is equal to 0. Right. Let's now discuss the solution of the problem in detail. We are given a 3 by 3 real matrix A. This is the matrix A. Define B, a map from R cube cross R cube to R, defined by B of V comma W is equal to V transpose AW. What is this? Look at B of V comma W defined as V transpose AW. By this time, you might have recognized this one. This is a bilinear form on R cube. And let V and W belongs to R cube. That means they are column vectors. V is equal to V1, V2, V3, the column vector. W is equal to column vector W1, W2, W3, the column vector belonging to R cube. Then, by definition, B of V comma W is equal to V transpose AW. Now, V is a column vector, V transpose is a row vector multiplied by A into the column vector W. Now, the row vector V1, V2, V3 multiplied by the matrix is V1, V2, V3, the row vector multiplied the column 0, 0, 1 is V3. V1, V2, V3 multiplied by the column 0, 1, 0 is V2. V1, V2, V3 multiplied by the column 1, 0, 0 is V1. Multiplied by the column vector W. Now this is V3, W1 plus V2, W2 plus V1, W3. Remember, this is the definition. Right. Let's call on the option 4. If B of V comma W is 0, then either V is equal to 0 or W is equal to 0. Right. Now let us take V is a non-zero vector 1, 0, 0. Let W be any vector W1, W2, W3. B of V comma W. Now take the definition. Then V1 only survives, that is W3 survives. The remaining things are 0. Now take a W in which W3 is 0. So let W is equal to 0, 1, 0. W3 is 0. And this is not equal to 0. Then B of the same V and W will be W3 is 0, 0. So BVW is 0. So here we have found two non-zero vectors, and the bilinear form, that is B of V comma W, is 0. So this we have B of V comma W is 0 for some V not equal to 0 and W not equal to 0. So which violates option 4. Therefore, option 4 is not true. Right. Right. We move to the option 3. There exists a V not equal to 0 such that B of V comma W is equal to 0 for all W belongs to R cube. Let us say, assume this statement is true. Assume that there exists a non-zero vector V belongs to R cube such that B of V comma W is 0 for all W belongs to R cube. Since this is true for all W belongs to R cube, we take W is equal to, first W is equal to the column vector 1, 0, 0. Now multiply. Now B of V comma W. Now substitute in the definition. Now W1 survives and the remaining things are all 0. Therefore, you will get V3 is equal to 0. So you can try for W is equal to 0, 1, 0. B of V comma W will be, so W2, that is W2 is 1 and V2. So V2 will be 0. And let W is equal to 0, 0, 1. B of V comma W is equal to W3 is 1. So V1 is equal to 0. So because, so this says what? B of V comma W is 0 for all W belongs to R cube will imply the vector V, the column vector V is 0, 0, 0. That is a 0 vector. That is, your assumption is false. Your assumption is false. So therefore, what is given in the option 3 is not true. Thus, option 3 is not true. Agreed? Agreed. Let's move to the other options. Right. Now, we go for B of V comma V. That means in the place of W, you substitute V. In the place of W1, W2, W3, you take V1, V2, V3. Then this will be V3 W1 will be V3 V1 plus V2 W2, V2 V2 plus V1 W3, V1 V3. So this is 2 times V1 V3 plus V2 square. So that's the B of V comma V is 2 times V1 V3 plus V2 square. Let's call on option 1. B of V comma V is 0 if and only if V is 0. Is it true? Is it true? That is, now if you take the contrapositive of it, V not equal to 0 will imply B of V comma V not equal to 0. Right? You can prove this, or we can talk about a contrapositive. Now, for V, you take 1, 0, 0 which is not equal to 0. Then we have B of V comma V will be 2V1 V3, that is 2 1 into 0 0 plus V2 square 0 square, it's 0. So is it true? Is it true? Is B of V comma V not equal to 0 when V not equal to 0? No. So therefore, this shows that the option 1 is not true. Agreed. So far, all the options 1 to 1, 3, 4 are not true. Let's go to option 2. It must be true. For every lambda belongs to R, there exists a V such that B of V comma V is equal to lambda. So let lambda be any real number. Let lambda be any real number. There exists a V is equal to column vector lambda by 2, 0, 1 belongs to R cube, yes, such that B of V comma V is equal to 2 V1 V3, 2 into V1 lambda by 2 into V3 1 plus V2 square, that is 0 square, that is lambda. So thus for every lambda belongs to R, there exists a V such that B of V comma V is equal to lambda. Thus option 2 is true. Summarizing all the options, the answer to this question is option 2. That is the detailed discussion of the solution of the problem from the section linear algebra, which is related to bilinear forms. And definitely we are familiar with quadratic forms, bilinear forms, and in previous year question papers also we have discussed some questions on bilinear forms similar to this. I am sure that you have understood the solution of this problem. Thank you for watching my video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I am going to meet you all once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.